Hi, welcome to this video series on how to build an energy payment dApp. My name is Ayuba Ojonugomo Azu, and for those that have been following me on the education ecosystem, you will know that I'm a software developer and a blockchain expert from Nigeria in Africa. And then if you have been watching my videos on the education ecosystem, then what we are going to do in this video series is going to be a little bit different. It's going to be a dApp, but yet we're going to change some little things here and there. For example, in this video series, we're going to create our own web wallet, which means we're going to generate Ethereum addresses on the fly instead of relying on addresses that we have before. And then we're going to also interact with Infura.io, which will enable us to connect to Ethereum nodes. So we are going to create the app without MetaMask. So we're going to create our web wallet and then generate our own Ethereum addresses, then connect to Ethereum nodes, just like how MetaMask is connecting to Ethereum nodes. But then we are not going to use MetaMask. So we're going to use this platform here, this API here, Infura.io. And then if you go to their website, you see Ethereum and IPFS APIs developed now on Web3. So if you scroll down, you will notice that some of the companies that have used these includes MetaMask. So in a way, you are going to learn how to create what the designers of MetaMask created. So we're going to create our own wallet. Yes. And with our wallets, we should be able to talk to the Ethereum blockchain. So meaning the app is going to run on any browser, whether Google Chrome, Internet Explorer, any browser. So the browser must not have Web3 injected in it using MetaMask. So that's something you're going to learn. And then, of course, Infura can help you connect to both Ethereum and IPFS. IPFS means Interplanetary File Protocol. You know, the blockchain, more so the Ethereum blockchain, storing data on the blockchain is quite expensive. So IPFS is a project where you can store files, huge files that will be broken down into chunks and then spread out to numerous nodes out there. Just like the blockchain, IPFS is decentralized. Actually, it's a decentralized system that you can use to store files. So that's just it. If you want to know more about IPFS, you can go to their website. I think it's ipfs.io. You can go there and then you can learn more about IPFS. So you can see IPFS powers a distributed web, a peer-to-peer hypermedia protocol designed to make the web faster, easier, and more open. So I think we're going to do a project on this because it's quite important we do that. So with Infura.io, you can actually talk to these nodes. You can talk to both the IPFS nodes and the Ethereum nodes. So we're going to create an application that we don't need MetaMask. And for those that are interested, for mobile developers, those that are mobile developers that are interested in creating applications like creating web wallets, mobile wallets for storing Ethereum and other altcoins, you can actually learn from this video. So you can actually learn from that. You can create your own wallet, just a simple wallet for generating Ethereum addresses, sending and receiving tokens and Ether. So that is that. And then this application is focusing on creating a payment dApp for buying electricity tokens. So what is electricity tokens? Now if you go to this website here, I just checked kca@academic.com. Let me just read this so you get to understand why we talk about electricity tokens. The advent of global systems for mobile communication, coupled with technological advancement realized in the industry of mobile computing and computer networks, has culminated in wide application of seamless data communication in the field of electronic commerce. Now, this is a project actually somebody did. This project outlines the design and implementation of an electricity token vending system that loads electricity tokens directly onto corresponding energy meters. So, for example, like in my house here in Nigeria, I have an energy meter in which I buy electricity token using my credit card, and then I load the units that I bought onto my meter. And then as I use the electricity, as I use my TV and other electronic devices that I have, the meter will keep on displaying, and the amount of energy I use will keep on depleting until the energy becomes zero, and then I have to recharge again. So that is that. So now this project will focus on that kind of scenario, but now instead of buying power with crypto, with the normal fiat, we're going to use cryptocurrency to buy that. We're going to use the Ethereum Ether to buy that, and by doing that, we're going to have our own web wallet. Now we have a popular website here in Nigeria called buypower.ng. You can see if you go to buypower.ng. Now here is where you can actually buy your electricity. So it doesn't have something similar to this, but now instead of buying with our credit card, we're going to buy these with Ethereum. We're going to buy this with cryptocurrency. So for example, if you click here to buy electricity, you can see my information is already stored here. I'm logged in, and then here's my meter number, and then here's the amount of electricity I want to buy. So if I click on payment information now, it will attempt to take me to a page where, okay, good, so I review my order, for instance. You can see, so let's say I want to buy electricity worth 2,000 naira, and then if I click pay, good, so now you can see there are plenty of payment methods here. I can use bank transfer, I can pay with card, I can pay with GT Pay, I can pay with this application, buy now, pay in 14 days, and I can pay with CSS. Now imagine an application like this where we'll also have an option where I can pay with Ethereum. So that's what we're going to do. So we're just going to have that option where we can pay with Ethereum here, and then of course, for we to be able to achieve that, we have to have a wallet attached to each account that is created on this kind of website. So that is that. Now at the end of the day, after making the payment successfully, a token will be generated for you, and then you can use that token to load onto your meter, and then you have power that you can use. But then we're just going to simulate that, because we're not going to generate that token, but we're just going to simulate that idea, because generating tokens itself is it's quite a complex scenario that is not is above the scope of this tutorial. So, but I hope you will get the idea. Now that's what we are going to create in this project. So stay with me while we move on to the next session, where we create our interface, design our smart contracts that will keep history of transactions, history of what we've bought, the energy tokens we've bought, and then you know, do this without using MetaMask. All right then, thank you for watching. Build an energy payment dApp. My name is Ayuba Azu, and in the last video session we did an introduction and introduced and had an overview of our energy payment dApp, and then we looked at the Infura IO, a way of connecting to our Ethereum nodes. And then we said we're going to create a web wallet that will enable us to connect to the Ethereum nodes without calling MetaMask. And then we also look at energy tokens, And then we discussed that at the end of the day, we are going to create our dApp in such a way that you can pay for those energy tokens using Ether, which is the cryptocurrency that powers the Ethereum blockchain. Now, in session 1 here, we're going to set up our application structure, which will involve designing our user interfaces. And then we're going to have the sign up process, the authentication, authorization, and user registration process. Then we're going to have the process of creating our wallet. And then, of course, last but not least, buying energy using Ether as our cryptocurrency. So I'm going to do this in Visual Studio, but actually you can do this using any programming language of your choice. Now, what I'm using Visual Studio is because that's what I'm more comfortable with. But the aspects that I'm going to touch now is not really does not really mean that you have to use Visual Studio. Like, what I just want to do is to create a registration page for the user to be able to log in. So you can do this by using any programming language. The most important thing we want to touch in this video tutorial is creating the energy payment smart contract, creating our web wallets, and then interacting with Ethereum nodes without using MetaMask. So that's our focus on this tutorial. So I have Visual Studio here, and I go to File, I go to our new website, and I'm going to create a new website just to have a simple interface that will give me the look and feel of what I want to create. So let me wait for this to get loaded up. Good, so I'm going to select ASP.NET Form website. Like I said, you can do this using any programming language of your choice that you're comfortable with. So I'm just going to call this energy payment. And I left this on HTTP. So I click OK. And the amazing thing about Visual Studio is this will create a complete web application for me where I can actually log in and do all that stuff. So let me wait for this to get loaded up. Just wait for this. You can see it's adding a whole lot of DLL dynamic link libraries to the application. Adding jQuery and all that, so we'll just wait for these to get fixed. And you can actually go out there if you need a template that's quite different from what I have here. You can actually go out there and download some templates that you think will be okay for you. So let's wait for this to get created. taking quite some time, but we can see that each of the libraries has been added to this project. The funny thing is we don't actually need all these libraries actually. I just did this this way because I want to leverage on the interface that Visual Studio is going to create for us. Okay, I think the project creation is successful, so let me wait to see these get loaded up in the Solution Explorer. Okay, why is it slow? Okay, so we have these projects created. You can see a whole lot of files, a whole lot of folders, and all that. And if I run this project, if I right click on this is the folder.tspx, and then I view this in Google Chrome, you will see that I have a full-blown web application that has been designed for us by Visual Studio. So we're just going to leverage on this design and then do what we have to do. But like I said, you can download any templates that you feel will conform to the kind of design you want. The most important thing is to teach you the concept of creating your own web wallet, interacting with your smart contracts through the browser without using MetaMask. And then we're going to use Infura.io, which is even the technology that MetaMask depends on. And then if you're a mobile developer, like I said in the beginning, you can actually leverage on this tutorial to create a mobile app where users can interact with the blockchain, the Ethereum blockchain, through your mobile app. So we're just going to learn that too. So this is a complete web page, ASP.NET, that Visual Studio has created for us. So we're just going to add some few links to what we have here. Like we're going to add, we already have registration and login here, so we're just going to add create wallet and then buy energy. And then I can quickly do that by going to my site.master, and this will be for the logged in template. So I can just what I'm gonna do here is what I've explained before, you know, in my other tutorials, especially in my last tutorials, that has to do with creating in these last tutorials that I create a web app that connects volunteers with elders in ASP.NET. So you can watch these tutorials here, 1, 2, 3, 4, and then you'll see you'll learn in depth about what I'm trying to do now. So I'm just gonna get in my login view, which I have here. I'll drop that here. So this will be for the logged in user. I'm gonna say logged in template, and then I'm just gonna do this. So the first one I said create wallet. So I'm gonna change the links accordingly later. Or I can just say wallets instead of create wallets. Wallets, that's the user wallet, and then buy energy. So this will be buy energy. Energy. So this will be for the login template. It means you have to be logged in to be able to do this. Okay, fine and good. And then There are some changes I need to make on the web configuration that I'm not gonna copy the entire codes and do that here. I'm just gonna look at my last project. Like I said, if you want to understand what I'm doing here, you can view my last projects so that you can get to understand this. So I'm just gonna pick my last project, which is all about okay, web app that collects volunteers with elders in ASP.NET. So we called it Elders Volunteers app. So I'm just gonna pick the web config of that, and okay, let me just let me pick the entire web config and then paste it here. Okay. Okay, so I can actually use the volunteers DB connection string to create my login information. So you just have to watch this video, the last video I did, to get to understand this, how to build a web app that connects volunteers with elders in ASP.NET. So you just understand what I did here by copying this code here. You understand how I was able to create this DB. Now the idea of creating this DB, actually, let me explain it. It's simple. It's just because I want to be able to store usernames and passwords on a table locally here. So if you can be able to create that usernames and password on your local host, then you're free to do that. So okay, I have this now, and now let me refresh this, see, and I hope there shouldn't be any error. Okay, good. So there is no error. So I'm going to change this name now, and then that should be my site master. That's my dispenser making noise. So I'm just going to change this to energy payments. Energy payments. So we have home, about, contact, wallet, and buy energy, and we have this registration here. Okay, so I can refresh this. And then I can change this interface a little bit. That should be my defaults. I can call these energy payments. And then I can just change this first narrative here, and then say learn how to buy energy tokens or energy or units of energy. How to buy units of energy. Units of energy. It's crypto. The remaining problem I don't need it, so I'm just gonna comment that out. So I'll refresh this now. Good. So you can see I've energy payment this. Now I'm just quickly gonna create my login stuffs, and I'll find that in this folder here. Go here, and these are the codes that Visual Studio has created for me, in which I explained all these in my previous videos, so you can refer to that and understand what's going on here. So I'm just going to remove all these codes, and remove all this, and then from here I'm going to say using system web security, and then okay, login button actually deleted that piece of code, so I have to do that again. So on click the login button. So I create that event and click the login button. It's unnamed.click. Anyway, that is the login button here. So I'm gonna say if membership dot validate user, passing the credentials, which is the username text, and the password text. If it's valid, then set response should redirect to of course gonna be default to XPX. I'm gonna say forms authentication, set authentication cookie, username the text, and then I set this to true. So this should we assume that our login interface should work. So let me quickly try that out and see. Let me see, I've created an account before in the last video, so I'm going to use that account. Let's go to login. See if I can still remember your account. Okay, I have these like this. So I have this account I've created in the last video. So since we're using that database, I believe this should be able to log us in. Okay, good. So you can see now this is the engine that I'm logged in, and you can see I have wallet and buy energy. Now, like I said, you can create these in any programming language. That's why I didn't really take my time to explain all this. Now you can create the process of authentication, authorization, and registration in any programming language of your choice. Now we're going to focus on creating this interface wallets, and that's creating your wallet and buying energy with the cryptocurrency that has been deposited in your wallet. Now one beautiful thing I said about this is this can actually work on any web browser. It mustn't be a web browser that have MetaMask installed or Web3 injected in it. So that's that about setting up the interface. In the next video, we're just going to design the user interface, setting up the wallet, designing the wallet interface, and then the buying energy interface before we proceed into designing the smart contract and then programming the smart contracts using Web3 technologies, and then see how we're going to wrap everything up at the end of the day. So thank you for watching. All right, continuing from where we stopped in the last video. I said we're going to create the interface for the wallets and then buy energy, but I'm even thinking we can integrate everything into wallets here. So let me just quickly change this name. I think I've done it before, so let me just quickly change the name of the application to be energy payment. Now what I said is you can actually do this in using any technology. If you're using any IDE of your choice, this mustn't necessarily be in C#. So I'll try as much as possible to keep this tutorial C# independent, even though I'm using Visual Studio. So for this authentication and authorization logic that I did, you can do this in any of your favorite programming language that you are interested in. But actually, this is not the main reason for this tutorial. So the main reason is for us to be able to create a wallet and then interact with the wallet, just like how MetaMask is, and doing this all without having MetaMask injected in our browser. So we want to create an application, that we can be able to interact with this application from any browser, even if we don't have MetaMask installed on that browser, right? So if I get to log in, going to log in, because with my password. Now this is just conventional authentication and authorization. Now we're going to do another authentication and authorization using wallet. So let me quickly create the interface, and like I said, I'm going to keep these to be HTML specific as possible. So let's assume you're logged in, and then so I can just drop that. So add new item. I think I should even make it an HTML page, so for those that will be doing this from another, will be viewing this tutorial using another different platform. So let's just say this is HTML page wallet. First of all, you've done your authentication logic, so we have wallet.html. So click OK. Good. Only if I do this, it's not going to be HTML, because if I do this now, it's not going to inherit the look and feel of the app. So that's be an EXPS application. But of course, you can do this in HTML. So I'll select the web form, and then I call this wallet. SPX, select master page. Good. And then we're going to have another wallet, new wallet. Let's have another page. So this will be new wallets. So for those that want to create new wallets, you can be redirected to this page and then create your new wallet. Right, so in the wallets page, I can make it a login and then buy energy from that place. So here now, I'm just going to create this interface. Start with the if. MD 12 text center. So I'm going to put this H1. That should be P2. Just give a little space, and then I can call this wallets. Right? Okay, good. So now I'm going to first of all create the interface where you should be able to log in to your wallets. I can give a space, maybe text center 2. So I give this div an ID. I call this div1. So I'm going to have different divs that I'm going to toggle the visibility accordingly. So the first thing we're going to do here is in this particular one, we're going to say let me try and mimic MetaMask, you know, since what we're creating is a wallet. So if we look at MetaMask, I want to mimic MetaMask the best way I can with no post bag and the rest. So if you come to MetaMask, let's try and log out. Good, so you can see welcome back, the decentralized web awaits. I think I like this. Then it says enter password or import using account seed phrase. Now in my own situation now, in our own situation here, we're going to use account seed phrase to be able to log in to our wallet. So I think we can just put this, the decentralized web awaits. So I'm just gonna put something like that. The decentralized web weights, even though we're talking about energy payments. Okay, good. So we have these. Then break. So here we enter our seed instead of password. Give it a width of let's say 450 pixel. Placeholder, so enter seed phrase. Enter seed phrase. Right. Type of course should be text. Okay, then we drop a button too. Just btn login to wallet. Of course, it's going to be a button, and then we're going to have a click event of it. But let's just style the button a little bit. So btn info. So you can see what happened to authentication. You first of all authenticated to the application, and then you also authenticated to your wallet. So put a break and put a link for those that are registering newly. If you want to add a new wallet, so you can just put SPX. Good, so you can create a new wallet for that. Now let's get to see that. I think if we go to offsite.masters here, wallets here, we can change these. Refresh this page, and then if you click on wallet, good. So you just enter a seed phrase here, and it's a seed phrase I had before. Although this practice of entering seed phrase on a website is not really recommended, I think for every website that you have out there, it's not really recommended to be entering your seed phrase on the website. But for this educational purpose, I'm just going to show you how we're going to create a wallet, and then be able to use our wallets to purchase energy tokens, since that's the aim of the tutorial. So the idea is we enter our seed phrase just like how this is, and then you click on login, then it logs you in to your Ethereum account by using your seed phrase here. You're going to retrieve your account, and then we'll get to see your account balance, and then you can purchase energy tokens with that with the Ethereum that you have. Or you can click on new wallets, and then you can click on new wallets, and then you create a new wallet. And to create a new wallet too, it's very easy. It's just basically the same interface. If I go here, I think I can just copy this, I will explain all this once we start programming the whole stuff. So I can just name this to be new wallet. So instead of exceed, now I can say entropy. So you enter an entropy value. Enter any text, you know, so that we can be able to create an entropy, to create a wallet for you. Change this, and then I'll change this to login. Or you can go back and log in. So change this back to wallets. Good. So we should have our wallets and our new wallet interface working. Okay, so you click new wallet. Good. So new wallet, enter any text to generate instead of this decentralized web await, I can just say generate a new wallet here. Generate new wallet's address. Good. So you enter this and you create or you click on login and then you enter a seed phrase and you should be able to log in. Now after logging in, the next thing that we need to have is for us to be able to purchase energy tokens using our Ethereum address. So I guess what I'm gonna do is because I just want everything to be done on the wallet here, so I don't think we even need this link by energy. We're going to have it once you're logged in. So let me just remove that from here. Just remove that from here. Okay, great. So I think for you to be able to understand this properly, in the next video I'm going to introduce you to Light Wallet, and then I'm going to introduce you to Infura.io so that you can see why we designed this interface to be like this. Now we're going to introduce Light Wallet, Infura.io, and then we're going to see how we can create an Ethereum address on the fly here. Can create an Ethereum address here, just like how you can create an Ethereum address using your MetaMask or any Ethereum wallet out there. So we're actually going to create our own wallet in this video tutorial. So thank you for watching. All right, continuing from where we stopped in the last video, let me try and log in back again. We're trying to create our wallet, our user wallets. Okay, let me log in with these accounts, and then here's my password. And then we were trying to create our wallet, right? We said you click on these and then you get to log into your wallet by entering the seed phrase. So you click login to log into your wallet. It's like doing a two-factor authentication. You can say that first of all you log into the app, then you also log into your wallet. But this is just a business rule I thought of. You can actually modernize this or modify this according to how you want it to be. Now, one of the ways we can actually interact with the blockchain, aside using that's with Ethereum blockchain, aside using MetaMask, is we can also connect with it through Infura. Now, Infura is even the product that MetaMask uses. Like if you come here, you can see go to infura.io. You can see Ethereum and IPFS APIs developed now on Web 3.0. Our development suites provide instant scalable API access to Ethereum and IPFS networks. Now this is Infura is brought to you by Consensus it's company. So Now you can see your access to Ethereum IPFS network, and if we scroll down, because actually build this is actually developers can connect to it. And I just want to show you something. Good, so you can see these are companies that actually use Infura IO, and you can see MetaMask is among them. So whenever you use MetaMask, you should know that automatically you're using Infura. And most of these, big companies like Open Zeppelin, Coinbase, MakerDAO, IDEX, and Crypto, Uniswap, a lot of companies, very big companies that trust Infura to enable them connect to the blockchain. Now, that is it. But another thing that, just 1 minute. Now, another thing is to be able to use Infura, you need to sign up and get an API key that you are going to use. I've done that before, but I'm just going to show you the process. It's very easy, and you just go to sign up, and then enter your email, your password, and you sign up. And after that, you get to see your API key. Let me try that again. Let me try using another email. I'll try using another email. Okay. I'll try using my Gmail and see. Okay, click the link to confirm your account. So let me do that on my phone, since I have the Gmail here. Still waiting for the mail. I haven't seen it yet. Still waiting for the mail. I guess I have to resend this email because okay, let's see, you can check your junk folders, right? So let me check my junk folders and see. Okay, well, I haven't seen the mail. Let me click resend. Well, if I don't see it, we can just continue because I've done this before. So I have a mail, I have a success, check your mail. Of course, that's what I'm doing. My inbox on my phone. Okay, good. I'm saying I think I saw 2 messages. Okay, so now after you do that, you confirm your email address, in which I'm doing that on my phone right now. I'm going to do that on my phone right now. So network is a little bit slow here, but just wait a little. Okay, good. So let me try to log in since I've confirmed the mail. Now, so I try to log in here so that you get to see the dashboard. Now, oh, good. So I think I've been confirmed. Right, you can see logouts. So it means I've been confirmed. So now the next thing to do is you get your API key, and then you can see a whole lot of things you can actually do here. Support mainnet and testnet. Now that's a beautiful thing. Support testnet for testing your applications instead of using the mainnet to do that. So click on this. Of course, I did verify my account. So we need to log in again. Let me log in again. Okay, so look at these accounts. Good. So you can see getting started. You can create your first project to access the Ethereum network, read step-by-step tutorial to help you set up your Ethereum API, and all other stuffs that you can do. Now, if we go to settings, go to settings, I believe should find our API key, and I think my network is a bit slow. Yeah, it's not fast. Okay, so now let's go right ahead to create a project. So let's give this project name energy tools or energy payments, energy pay. Okay, good. So we've created that project, and then this interface has changed a bit compared to last time I visited. Good. So you can see my project has been created, and then I have project ID and project secret. Now you should, of course, you should know that this keys needs to be secret. And if I'm going to access the Ethereum network now, this is my if I want to connect using any of my web browser, this is my endpoint for mainnet, and for testnet for Robston, I like Robston more. You can see it's the same thing, so it's just the Robston that changed, but the key is still the same thing. So now we are going to use this to be able to interact with the Ethereum blockchain and create our Ethereum address, interact with the Ethereum blockchain without going through MetaMask, because what we're doing is the same thing MetaMask did, that they had the application. So now that we have this now, let's go back to our application. Now the idea is we said you're going to create a new wallet, right? So you click here, and then you create a new wallet by entering any entropy here. Now let me introduce you to lightwallet.js. Let's go to light wallets. Just type it, light wallets, L-I-G-H-T. Okay, you can see we have light wallet example here. So I search these on Google. Good. So go to your GitHub page. Now we get to know a bit about Light Wallet and how we can use this to easily. So you can see here, Light Wallet is a HD wallet that can store your private keys encrypted in the browser to allow you to run Ethereum dApps even if you're not running a local Ethereum node, which is what we plan to achieve. Now it uses BIP32 and BIP39 to generate an HD tree of addresses from a randomly generated 12 words. And if you can remember, I showed you here that we can enter our 12 seed phrase. Of course, if you're creating your wallet, you know how to do that to be able to log in. So Light Wallet is primarily intended to be a signing provider for hooked Web3 provider through the key store module. This allows you to have full control over your private keys while still connecting to a remote node to relay signed transaction. Moreover, the transaction utils function can be used to construct transaction when offline for use in example air-gapped cold wallet implementations. Well, anyway, so the Light wallets can we can use that to store our private keys that is encrypted in our browser. But of course, just good, before I even noted that it says here, please note that Light Wallet has not been through a comprehensive security review at this point. It's still experimental software intended for small amounts of Ether to be used for interacting with smart contracts on the Ethereum blockchain. Do not rely on this to store large amounts of Ether yet. So the warning is there. Now, but we are going to implement this to be able to create our wallet, and then we can use, the idea is we don't want our customers that want to buy energy to have to, you know, install MetaMask in their browser and do all that. So we want them to just go to our site directly, and then the sign in, the sign up, they have their wallet address, they fund their wallet address with Ether, and then they buy their energy tokens, and they get to see the energy unit they have. Now if you read through, you will see how you can implement the Light wallets using JavaScript, and then we can scroll down a little. So but I'm just going to show you the necessary things. If we scroll down, you can see everything here. Now you can go to example, and then you can even run a web example to see how this works. So we're going to pick some of the codes here. Now you can see they have this web wallet, right? So we can open this. And then you can actually copy all these codes here and then use it. But then one thing is we need to have these libraries here: light wallet min.js, web3.js, hooked web3 provider.js, and async.js. So you can copy this code, paste it in any of your text editor and run it, and you will see that you will be able to create an Ethereum address as easy as you can. But then if we open this, good, so you can see we have these light wallets here, JavaScript, and then I think if we open library, we're going to see some JavaScripts here too that we can use. Good. So let's pick this JavaScript here. Anyway, I've downloaded this before and I've used it, so I have all the files here. You can copy the files from all the files in this folder, and this folder. But I've done that before. So if I go to my downloads, and then I go to this app, which I've done this before. So they are all placed inside JavaScript here. So you can see now I have this hooked web3 provider and just all that. Now the pretty most important wallet that I need here, I need web3, I need light wallet, and then I need hooked web3 provider, and then async.main that I showed you how to get. So I can just copy this JavaScript, JavaScript, and then put this in my project. Good. Now, like I said, you can copy all that from here. You can download all that from here. You have light wallet, in which you can pick from here. Then you also have if we look at this library, we also have is there async keystore.js? I think you need that. We have that too. Keystore. Okay, I can see that. Well, anyway, if you go to the example, let's just go to the example, and let's go to this example. Okay, so we need to pick some of the JavaScript from node modules. So you go to the node modules folder, and then you pick some of it. So you pick light wallet from this folder, this, and then you pick the remaining from node modules folder, which node modules folder. How did they arrange all this? Well, anyway, I can't seem to find the remaining JavaScript. Well, since I'm uploading these, you can pick this from the project files on the education ecosystem, and then you can use that. Okay, so now I've added that to my system. The next thing is if we go back to wallet, and more especially new wallet, right? So we want to create a new wallet, and then by their example, I need to open this example so you get to see. Just make some few modifications here and there. So we need light wallet, Web3, hooked Web3 provider, and async.js. So I'll just go right ahead and pick all that. So light wallets, okay, hooked Web3, then async, and then Web3 itself, we need that. So 1, 2, 3. So now good, we need this 4. Now the next thing is we're going to create which we already have it here from the examples here, but I'm just going to take you through one by one to see how we're going to use this. So we're just going to first of all set up our Web3 and then our key store so that we can be able to generate a new address, and then you know, you can also get balances of address you created. You can set seed, you can create a new wallet. So this is what we're going to interact with first. So I'm going to walk you through creating that, which we're going to get started right now. So I think I copied this down somewhere so I can explain it to you as we type the codes. Okay, good. So now as a script type of text JavaScript. So we start with the first variable. We declare our Web3, right? So we declare the Web3 object, and then we also declare global key store, which is where we store our private keys. So then we'll create the first function called set Web3 provider using our key store. So that's what we're going to do now. So function set Web3 provider using our key store, passing key store as parameter. So we get a new Web3 provider, just new hooked Web3 provider. Now if you look at the light wallet, you read through the API, what's the JavaScript codes, you will get to understand all this. This has been explained there. Now good, our host now is where we need Infura. Now our host is, we're trying to connect to the Ethereum blockchain, and one way that we can connect to it is what I just showed you here, which is of course using the, so we've registered our application on infura.io, and our host is going to be this endpoint. So I'm just going to copy this. So Robson.infura, since I'm using the Robson network, and then here is my key, my project ID key. So copy that. So you paste that there, and then transaction signer should be the key store. So transaction signer should be the key store, right? Now after everything, now we see Web3 let's set provider. So Web3 provider. Good, so we've created that. Now the next thing is we are going to create the new wallet function that they have. So we're going to look at that as in creating a new wallet. So we're going to create a new wallet function. If you look at it, it's here. We're going to create this function, but we might do a little modification here and there. So I'm just going to type this because I've typed this down. So I'm just going to type it again and then explain it to you step by step. Okay, so let's start. Let's say function. So new wallet. You can actually copy this directly from the site, but of course you're going to make the changes I'm going to make. So extra entropy. Now this entropy is a way of enforcing and a way of strengthening your private key. So which will be documents. Let's get element by ID, which is this. I call this X entropy. So it's just, you can write anything there. Element by ID. So I say X entropy value, and then of course this after getting the value we make it empty. Then our random seed, we declare our random seed should be light wallet. Key store generates random seed, generate random seed by adding our extra entropy. Extra entropy. So good. So now after doing that, we are going to display the random seed based on the algorithm that based on the different algorithm that is used to generate this kind of Ethereum address. So let's save with info string. So we say your new wallet. You can just copy the texts that they have here, so you can see. So it's actually prompting you to write down your random seed, your 12 seed phrase. So the system will prompt you to do that, and then to do that prompting, while it will tell you to encrypt your seed with a password. So we're writing that now. So we're encrypting our seed with a password. Prompt info string. Now you can give a password here, but I can just write this password down, or the user can change these and put any value he feels like. Okay, so we say light wallet, key store, creates vault. You have to be careful about the camel casing. So password is password declared above. Seed phrase random string. Now this is salt that if you go here you can see explanation, random salt that's we're generating, you know, to strengthen the creation of the good. So after this, here we now say function. It's an arrow, and then the key store is successful. So now the global key store that was declared above should carry this, and then now we're going to call another function called new address or new addresses as it is written, passing in the password. And then of course we're going to call this function set web3 provider. Set web3 provider. Say global key store. Now we just verify that everything is correct. Can your addresses will pass in the password, not capital P, small p. Good, you can see they have get balances here, which we're not going to call this now. So we need to create these function new addresses, in which if light wallet has already done that, we need that. So good, new addresses, which is this. So we're going to copy that too. We're going to put that down too, and then we should be able to generate our Ethereum address once we have this. So I'm going to create this function new addresses. So I'll go down right here. Function new addresses, passing in our password, parameter. So say if password is empty, then password should be prompt. Enter password to retrieve addresses. Enter password to retrieve addresses. Now note that we can generate more than one address using this method on the fly. So we'll say global key store. Key from password. Passing in our password and then calling this function. Let's check if there's an error or there is a success where we get a derived key. So if everything goes fine, capital so that you get to see everything. So we'll see global key store, generate new address, passing in our derived key. Now you need to know all about derived keys, and you need to know about the securities of the blockchain. Now you can see here I passed one because I want to generate only one address, but if you look at theirs here, they declared a number of addresses they want to generate, and then they have it here. So but I just now want to generate only one address. So now after doing this, I need to display my address once it's been created. So let me look at it. So once you go to new wallet, right, so you enter any text you create. I will just display your Ethereum address. Okay, I can actually display it up here. I can just see new wallet has been created. I can display that there. Oh, I can toggle this this to be okay. No, let's just add it up. Can display it as a message. I can just display it as a message below. I'll just say what is the div, or maybe H5 for example. I can just say new address has been created, so I can just display that there as a message. MSG new address. So that I can say documents, let's get elements by ID. Message new address, MSG new address, in a HTML. Should be addresses. Let me check what I'm doing is correct. Okay, good. Variable addresses. I can declare this. I need to declare that. Good. Then I can display it based on what they have here. So now they have this function that's the added, which I don't need that now. So this should display addresses, and I can just put a message here. I can say your new address, new ETH address, which is this. Has been created. Log in to your account with electricity. Good. So as simple as this, we can just call this. You can see on click. We call the new wallet, right? The new wallet function. So we call the new wallet function, and hopefully this should work fine. Now let's test this. So any text, I can just say AAA, and then click on create. Oh, sorry, create a new one. Yes. Okay, something is not working fine. New wallet, of course, new wallet. Okay, I guess I'll pause this video here and then test this and see any error that I've encountered, and then I'll let you know in the next video. Thank you for watching. All right, continuing from where we stopped in the last video, we were generating a new Ethereum address, and then we actually encountered an error, in which the error was actually typographical error, so in which you need to look at your codes and check that. For example, here I declared random seed with capital S, and then later on I use small letter x, so you're going to change that to capital S or small letter s accordingly. Then if you still scroll down, I think info string was also different, and password here I used capital letter P, which was supposed to be small letter p, and then the random seed here also was small letter s, so you need to correct that. And then I think that's that about new wallet. So that's so just fix those typographical error, and once you fix them, the next thing is let's generate our new Ethereum address, and then we should be able to log in to the Ethereum address and retrieve our balance to see the balance of Ether we have. So, and that's very easy. If you come back to your wallet, like I said, first of all, you enter any text to generate an entropy. So I can just write anything. I can write my name, for example. So you click on the create button. So you can see the new wallet seed. Your new wallet seed is this. So you copy this, please write it down on paper or a password manager. You'll need to access your wallet. You will need it to access your wallet. Don't let anyone see this seed, or they can take your Ether. Please enter a password to encrypt your seed while in the browser. So I can leave this password, this default password here, or you can write any password there. Now I'm just going to copy this. So here is my wallet. And now one beautiful thing about using Light Wallet is, now that I've copied this wallet seed, I can restore this on any Ethereum wallets out there, be it MetaMask, be it any Ethereum wallet, be it my Ether wallets, any Ethereum wallet. I can use this wallet seed now and retrieve my wallet. So I'm just going to save this. I'll just save this like this, and then so future purpose. So now that we have done this, so you click OK, and then we wait for the Ethereum address to be generated based on our wallet. Good. So you can see now I have this address. Your new Ether address is this, has been created. Log into your account is a seed phrase to purchase electricity. So now the idea is, now you click on login. Since we're able to generate our wallet, you click on login. So the idea is we enter our seed phrase here, and then after entering it here, I click on login, and then it logs me in to this wallet, and then I retrieve my balance. So that is the idea. Now, and that's very easy. So we're going to program that now, and what we need to do is to retrieve balance. And if you look at etawallet.com, the light wallet, sorry, you can see they have a code for retrieving balance, which we have here. They have this get balance, right? So what we're going to do is once we click on the login button, we are going to still yet we're going to still yet call these no, not show seed, set seed. Good. So we're going to call set seed or password. Let me see. Enter password to encrypt your seed. Okay, we're going to call this function. Yes, we're going to enter our seed, and then we click on it. It tells we put in the password to encrypt that seed, and then this will create this vault, and using that password from our seed, we generate our new Ethereum addresses, and then of course we can retrieve the balances of the Ethereum address that we generate. So okay, so that's what we're going to do now, and to do that is very easy. We go back to our login page. To our wallet page rather. So I'll just copy all this scripts and then go to wallet and paste this up. So the idea here is I want to log into the Ethereum address. I want to log into my wallet rather and display my Ethereum address and the wallet balance. Okay, I have this, but first of all, once I click on login, I'm supposed to hide this the way I planned it. I'm supposed to hide this interface, this div here, and then display another div. So I'm going to do that now. Let's call it div2, same class, md12 text center. div2, and then h3 I can say I think I can just say your Ethereum address. Then I display the address. Yes, I think that's what will be better. Let's say h4. I'll display address. Let's say ID x address. Right, then below that I display the balance. And then we'll also need to display the energy balance. So I think that's how we need to do that. can say H. This should be like H2. Say X balance. That's where I'm going to display the balance of the address. And then H3 energy token. Energy token balance. And then H2 X token balance. Good. I'm going to explain all this. It's going to make sense at the end of the day. The problem. So the idea is once we log in successfully, we toggle the visibility of the first div to false, and then we toggle this to true while we display the, for now, while we display the Ethereum address and the balance. Now, let's go right here, and then I'll pick the new wallet. We need this function. This first functions. We need that. Basically everything we need actually. Okay, sorry. Let's put this in scripts. Scripts type text JavaScript. Okay, good. Then let me see, we also need to we don't need new wallets. Of course we will need this new address. We need this. Yes, we will need this. So copy this. Or let me type the code so that you see where we'll need this instead of just going straight away and copying this. So this is the function that we're going to use. Function set seed, which light wallet is already defined for us. So we say variable password should be prompt. Enter password to encrypt your seed, just like how we had it. Enter password to decrypt. This should be to decrypt your seed, not to encrypt, since we are planning to login. So decrypt your seed. And then I'm going to leave the default password that was there that I wrote. Then now light wallet key store creates fold. So password will be password that we provided, and seed phrase will be this file we're gonna have here, exceed. So we just say document get elements by ID. should be, of course, if you look at it, we have it here, so I'm just going to copy directly from there. So I'm just going to copy that directly, paste that here. And once everything is successful, or if there's an error, we can check. So global key store that we define above, should be the case. Document, get elements by ID. Now we make exceed to be empty. This to be an empty string. Then now we call the new call this function the new addresses that we're going to paste now, passing in the password. And then we also call this set web provider, set web3 provider, passing in the global key store. Okay, good. Now I can just go right here and copy this piece of code, since we've done this before. And then we'll paste this here. Okay, so with this we should be able to we should be able to display our so we do this, we call get addresses, and then once everything is successful, okay, good. Now I'm retrieving the address here actually, because I've decrypted the password and the seed phrase. I'm retrieving the address here. I can call this retrieve address instead of, so as not to confuse you, let me call this retrieve address instead of new address. Let me call this retrieve addresses. So here's what's happening. We enter password to decrypt our seed, and then we check the Light Wallet key store, where we get the password using the password and the seed phrase, and this holds. We check if we do a function check if it's successful or not. If it's successful, then we call this function here to retrieve addresses based on that password and that password that we sent, and also of course set web3 provider global key store. Now we call these, and then I need to enter this password again to retrieve addresses. I don't really think so. I don't think I need this, even though it's there. I'm going to check this actually. So we get key from password that we passed, which of course is this password. I've already entered it here. And then once we get the addresses, we need to display it, right? Now in displaying it, here is what we are going to do. First of all, I'll make the first div, which is div1, I'll toggle it to false. So we close this. So I'll say document gets element by ID. And get element by ID. Div1. It's hidden. True. And document gets elements by ID. Div2. Should be false, so that means first of all, I need to put the hidden. This one. I need to first of all hide this. So this won't be displayed once we're on Windows load. So now, once we're able to do that, now I want to display the address here, an X address here. So I can just say X address. Just say X address. Now HTML should be I don't really need this text. Good, so I should be able to display this. Now remaining the balance, so we need to get the balance for that particular Ethereum address that we just generated. So we need to get the balance of it, and that's also easy. If you look at what Light Wallet has here, you can see we have these get balances, in which we get the addresses from the global key store, and then okay, we have this async here, passing in the address, and then we get the balance for the address. And now we get the balance for each address. Now that's very easy. We're going to do that now. So I'll say function gets balances, addresses should be global key store. We have declared above. At this point, global key store has been modified, so it's already having the address. So get addresses, then declare balance. So we say async dot map addresses web3 of ETH gets balance the normal way, getting balance using web3, passing a function of either error or results, which of course the result is going to be the balance. So async.map tree.eth get transaction count, and then function, we check if there's an error, and then we get the nonce. I don't really see this important now because we're not really using that anyway. So the balance should now be says 0. We get this, you know, Ethereum is the Ethereum ether is usually to 18 decimal points, so we get this, we do this to convert it to. Now after doing this, now I can display the balance actually, and then I can display some X balance, have X balance here. So I will say document dot get element by ID, and get element by ID, X balance, HTML should be balance. Good. So now where are we going to call this get balances? We can call it in retrieving addresses here. You know, after retrieving the addresses, we can call it. So I can just call get balances. Oh, it's actually supposed to be get balance actually, to follow the English properly. Okay, so let's test what we have. On login, let's call this function first, and hopefully if everything is fine and good, we should have what we want. Okay, so we enter our seed phrase. That's the old seed phrase. This new seed phrase I created, just this, which yours is going to be different from mine. So enter this, and then we'll click on login. Now enter password to decryption C. Of course, it's this password, so that I use. So I click OK, and then I wait for results. Good. So you can see my Ethereum address has been generated. Now waiting for my balance. Okay, it's open balance. There's nothing. Okay, I guess there's a mistake in getting the balance here. And of course, in getting balance, I need to make these to be I need to put I'm just thinking of something to do. Okay, how about if I do like this? So in getting balances, let's see if we've made any mistake. Probably maybe typographical error. addresses. Global key store gets addresses. Web3 ETH get balance. And balances here. Sync map addresses. Okay, so I can see the second error. Web3 to get transaction counts, and then function error announces. Okay, good, and then we can now display our balance, right? Okay, balance, so it should be these balances. Good, so I think we can try to log in again. Okay, what's our seed phrase? I'll leave it as password. You can actually encrypt your own password differently. You can use a different password. You mustn't necessarily use that password I used. Okay, so you can see 0 ether. There's currently no ether in this. Good, so we're able to retrieve our balances, but I don't like the way it's displaying. Okay, I hope I'm not going to use that ether for calculation later. So if I'm not going to do that, let me just put this like this for now. Or let me make it like this. Then I pick this, then I drop it in here. So you can see we have these just like MetaMask. So enter seed phrase, click on login. Good. Now you can enter this on any of your web browser without, even if you don't have MetaMask installed, and you can try this in another browser. And you're going to see that you have your Ethereum address and your Ether. Now you can send in Robston Ether to this address, and you're going to see the value. So let's do that. Let's copy this address. I have some Robston Ether here on MetaMask. So I'm going to send in some Ether to that. Okay, good. So I'm going to send in some Ether to this newly created Ethereum address. I'm going to send in 0.89 Ether. just wait for this ether to be sent, and then we're going to see the balance. And then we can actually also check that on Etherscan and anywhere, you know. Good, so ether has been sent to this address, and refresh this page and relog in again. Good, so you can see we have 0.89 ether. Now we can check these on Etherscan. Check our Ethereum address. So go to Robston, etherscan.io. Seven seconds ago. Probably maybe this is mine or this mine, I don't know. Good, so I search for this Ethereum address. And you can see 1 minute ago 0.89 ether was sent to this address. So, and that's that. So you can, if you check these now on the mainnet by removing Robston, you still have your Ethereum address, only there's no ether in it. Good, so you can see there's no ether in it on mainnet, but we have this address now existing. All right, so we're able to log into our application and then send in some ether to see ether balance. So now we are going to use this ether balance at the end of the day to purchase energy tokens. So you can see I have energy token balance here, in which I've not displayed anything yet. So we're gonna have a button at the end where you click to purchase energy tokens with this your Ethereum address. So for us to do that, we are going to create a smart contract that will enable the purchase of energy tokens. And like I told you in the beginning, the idea is like in Nigeria we have a meter, an electricity meter for every household, where you load it with energy tokens actually, and then your meter reads as you use electricity. The meter gets to burn the energy tokens depending on the your consumption of electricity. So we're going to mimic that in this dApp that we are creating. So we're going to assume that all these things we are doing here will be encoded into a hardware device like the meter, where you can log in, you get your Ethereum address, and then you buy your energy tokens, in which the energy tokens will now be loaded into the hardware that you're going to use. And as the hardware is working, as you're consuming electricity, the energy tokens is being burned slowly. So you see how much units of energy you have bought. Should I call this energy token balance or energy unit balance maybe? Anyway, we will look at that accordingly as we go into the next video. So in the next video now, we're going to create our smart contract, and then we're going to create our energy pay smart contract. And then we are going to see how we're going to interact with this smart contract. We're doing all these things without interacting with MetaMask, so without using MetaMask at all. All right, thank you for watching. Hi, welcome to session 2 on how to build an energy payment dApp. My name is Ayuba Ojonogo, and in the last video we were able to create our Ethereum address, and then able to create an Ethereum address, and then also send ether, rather Robston ether to the Ethereum address, and we're able to display that on our wallet. So in this video now, since this video session here, since we are discussing how to create an energy payment dApp, we're going to create a smart contract that will enable us to pay or to purchase energy tokens using the ether that we have in our wallet, and we're going to do all this without using MetaMask, and then we're going to see how this works. So you head to remix.ethereum.org, which is an online IDE for creating smart contracts, and then you quickly go to create your energy payment smart contract. But before we do that, you can import the Open Zeppelin Safe Math smart contract, which I have here, safe math SOL. So, and to do that is easy. You just go to openzeppelin.com, or you go to the GitHub page by going to this URL that I typed here, github.com, open Zeppelin contracts tree, master contracts, like this. So you go to that place, then you can see math. So you click on math, and then you can see safe math.sol. So you can copy these codes completely. All these codes, you can copy that, and then you can create a folder math and then put safe math.sol in it. So that's that, and you can watch my video tutorial on how to create a payment dApp leveraging an Open Zeppelin. You can see how I did this. Now in this session here, we talked about creating energy payments smart contract. So you click on this plus button here, and then we name this Energy Pay. So that's our smart contract. So I go right ahead and click OK. Now, of course, we're going to creating our smart contract by starting with pragma solidity. .6.0, so compiler above 0.6.0, and then we're going to import the Open Zeppelin, the safe maths of the Open Zeppelin smart contract. So I have math, and then safe math.sol. So I have these now. Our energy payment smart contract is going to be like this. We're going to create a token, and then the token will give the token a name of energy token, and then we are going to after creating the token, we are going to create a mint function and a burn function, and the mint function will be called anytime anytime payment is being sent to the smart contract address. So if you send Ether to the smart contract address, the smart contract will automatically mint some energy tokens for you, and that energy tokens will be added to your address, the address that calls the mint function. And then it's now assumed that the address is what is in the meter, and will be reading automatically based on time. The bond function will be reading automatically. I'm just going to show you how all this is once I'm creating the function. So I can start quickly by typing contract energy pay. Okay, so you always start this. Now we're going to use using safe math. Using safe math for UING 256. So I'm going to declare some variable like the token name, symbol, decimal, total supply, and then transaction counts, because we need to keep a transaction counts for all transactions as we made. So I'll call this name, that should be token name, string private. Token symbol, then 28 decimal, so decimals, which of course is going to be 18 decimals, then 256 private. We need to see the total supply of the tokens that are currently in circulation, and then we need to declare a transaction count 256 private private txn count. So every transaction that is being sent, every main function that is called, we keep a transaction count. Now we create a mapping of all our addresses. We get the balance of all our addresses. So mapping address, we map that to 0256 for all our addresses. We get the balances. So we can get the balance by we map each address, we get the balance of each address. So now we create a structure, the transaction structure. So I call this txn info. So that will be transaction structure or transaction info. And we have these, the customer's address, customer's Ethereum address. Then we have string, customer name. And we have unit bots. And we have amount paid, that's in Ether. And then of course we need the meter number. This is just to keep a record of all transactions made. So this is address. Now we also create a mapping. We map each transaction info. C256 tx info, and then we create an array where we store each of the transaction types. So this is like mimicking a foreign key primary key representation in relational database design. That's what I'm doing here. I'm trying to mimic that. Public tx and count. Good. So now I have this. The next thing is to create my constructor. So we can give our energy tokens name. So it's a string, memory name, string, memory symbol, as a token symbol, 9 decimals, which of course is going to be 18. So we call this public constructor. So I say name should be the name that I'm going to provide. Symbol, which was declared up. I'm calling all this global symbol should be symbol, and decimals should be decimals. Now okay, expected identifier, but got this. Constructor, not constructs. The keyword there. So we'll create an event. I'll just call it transfer, since we're transferring from a zero address whenever the token has been minted. You send Ether to the smart contract, and then it means energy tokens for you. Let's index 2. Value, right? That was sent. So we can return the name of the token, the energy token. So say public view returns string memory, and then this should return the name. So the same thing for symbol and for decimal. So let's say function symbol public view returns string memory. So return symbol. Then we can return the decimals to function decimals. Public view returns so we return decimals, right? Just give space. Now we also get the total balance, and then we get balance for each address, the token balance for each address. So function total supply, so that we can get to see total supply of tokens, energy tokens in circulation. So public view returns 256. So this should return total supply. Okay, identifier not found or not unique. Did I declare total supply somewhere? Okay, you integer like this. Then I get balance of tokens for each address, so I call this balance of. So we're passing the address as the parameter. So I'll call the account. And also public view returns 256. So return balances of accounts. Okay, good. So now here it's where the main function, we're going to call the main function, which is going to be the mint function. So we can be able to mint energy tokens whenever ether is sent into this smart contract address. And to do that is very easy. So I just say function, call it mint. I need to pass in the address as the parameter. As an account calling that, and then string call data customer name. Now we use call data because we are going to this function here will receive ether. So string call data again, meter number. So this contract will receive ether by making it external payable. This can receive external ether. So first of all, we have to check that the account calling this is not a zero address. So we do that. So require that the account is not a zero address. So it cannot mint to a zero address. So transaction count will increment that by 1. So good. So here's where we're going to use our safe maths. So we do add 1. Right. So the unit bought, unit of electricity bought, should be what you sent, the value of ether sent, times, we could say 1 ether should give you 1000 units of energy. So using this, I just say 1000. Now you can change yours to be any value. You can change it to 2000 or any value of your choice. So now transaction info TXN should be and count. Good. Recall we're counting the transaction. So TXN customer address, of course, should be the account that is calling that. Customer name, TXN dot units bought, and amount paid, because the ether received is the amount paid. TXN dot, it's called meter number, should be our meter number here. Okay, so you can see this is set automatically. The Solid compiler is compiling everything as we want. Now, so we're going to update our total supply after doing this, and then simple as saying total supply should be equals to total supply add units bought. So we add that value to total supply, and then the balances of accounts units bought. Good. So the transaction count, we're gonna add that to the array by using push JSON count, and then we emit the event by calling the transfer So we say from address 0 count and then units. Units ports. So now the next function will be the bond function. Now this function, we're calling this function whenever ether is sent into a smart contract. So energy tokens will be emitted according to the value of ether you send onto the smart contract from your wallet. So think of our application as an application where you can pay for energy token, you know, as a MetaMask kind of application where you can pay for energy token. So we're creating the bond tokens with bonded tokens, which will mean as you're using the energy, token amount is being bonded. So this function can be called by a physical device. So first of all, we require that the account is not a 0 account. Just say not a 0 account. Cannot bond from 0 account. Then we update the balances. Accounts should be balances accounts. So we subtract by calling from the math from line open Zeppelin. So we put amounts, just put a message here. Now, so we update our total supply. So we total supply and subtract amount, of course. Right, and then we also call this transfer event, emitting transfer account address 0. So bond into the address and then amount. Okay, good. So now that I've created this, let me see, I have a problem. Now, we're going to create a function to get transaction based on each the transactions that we store transaction count in the array. We're going to get a transaction by each of the array number. So function, I can call this get txn, and then we're passing this number like 1, 2, 3 up to like that. So view public returns so address string memory. string memory. So we're going to return tx info, passing in count, we get the customer address, passing in info, count, get the customer name, passing info, count, we get the amount paid, I'll get the units bots, right? Then amount paid, let me look at it correctly. Address, yes, for the address, and then customer name, units bought. Okay, good. Units bought. Then it's also good we get the amount paid and the meter number. And if that's the case, I'm gonna do this like this. Units 256. Transaction info. Amount paid. Transaction info, count, and then last but not the least, which of course is meter number. So with this, I think we've come to the end of creating our smart contract. So you can see we created this smart contract. First of all, we declared these private and global variables, and then we create a transaction structure where we want to store each transaction that was made. We want to know the customer address, customer name, units of energy bought, amounts paid, and meter number. This is for accounts keeping and record purposes. So we map each of the transaction information, and then we keep an array of transaction counts. So on the constructor of the application of the smart contract, we're going to give the energy token name, symbol, and decimals, and then for each successful transfer of minting or burning, we call this event. So if we scroll down, we can get the balance of each account by typing in the Ethereum address, and then we can mint tokens, energy tokens, once payment is being made to the smart contract. And then of course we can burn energy token. This should be based on time, like they should be calculating based on time. So this, the physical device can actually call this function here. And then of course we want to get the transaction information, and then we call this function. All right, so that's that about creating the energy payment smart contracts. In the next video, we're going to interact with the smart contract and see how we are going to wrap up everything at the end of the day. Thank you for watching. All right, continuing from where we stopped in the last video, we were able to create our new wallets, and then we were able to check balance of Ether deposited to that wallet. Now in this video tutorial here, we are going to interact with our smart contracts to be able to mint energy tokens by sending in Ether to the smart contract address. And then that means we are going to modify our interface a little. So here's the function we're going to call, send Ether to this function. This is external payable, and then the code in this function will run, which means we are buying energy tokens, and 1 Ether should be 1,000 energy tokens. So so that's what we are going to do now. And let me see, we're emitting the energy tokens, increase the total supply, and then the balance of accounts we add. Okay, all right then. So since that is the case, we're going to modify our wallet a little bit. So we're going to add a button here that will say buy energy, and then we're first of all going to display the energy tokens here. So we'll have a button here, buy energy, and then you fill in your details, which of course is going to be your customer name, which is going to be the customer name, the phone number, customer name, and the meter number. Those are the two things that we're interested in. So the other things are going to be captured automatically. All right, so if that's the case now, just the way we did this, we are going to do something like that too. So we're going to copy all this, and then you can see everything is happening in one interface here. So call this div3, and then say buy energy. Say buy energy, and then what we need is I can make this a table. Let me just enter details. Enter details to buy energy. Okay, so we have this. So I'm gonna create a table. I'm gonna style it, and then so width should be maybe 60%. And then tr here, say customer name, so like I said, if you notice, I'm using HTML control throughout, so that for those that are not familiar with C# and ASP.NET, they can follow this tutorial. So I'll call this X customer name, and then the same thing, it's going to be for the meter number. As the customer's meter number. So say S meter number, and then I'm gonna paste that again. Drop a button. Okay, input type button, and value is make purchase. Okay, good. So okay, we need customer name, meter number, and then the ether you're depositing. Yes, the let's say ether amount. Ether amount. Change this to X amount. And then I can put a small note here just for customers to see. Say note 1 ether gives you 1000 units of energy. Right, so we can just say BTN purchase. Right, good. So we have this interface here, and then here token balance, right? So I just put a break, put the break twice, and then I can say buy energy by dropping this button here. Buy energy. So on the click of this button, just buy energy here, what we want to do is once you click on this buy energy button, then we should be able to toggle the visibility of this to be true and the visibility of this div to be false. So that's what we're going to do. And then so let me just create a function for that. So we'll leave div1 hidden to be true, div2 hidden to be true, and then div3 hidden should be false. Try that hidden should be false. So that's the only thing that will happen once you click that button. Okay. So let me log off, and then I'll try to log in again. Log off, try to log in again. Okay, good. So let's say log in. Click the login button. So I'll go to my wallet. Log onto my wallet by entering my seed phrase. Okay, so I retrieve my Ethereum address. Now you can see I have the buy energy button, in which if I click this, oh sorry, I need to register that event here. So I'll click this. Say buy energy, small letter E. So I'll refresh this page again. This login. Okay, enter details to buy energy. Note 1 ether gives you 1000 units of energy. So you just enter your customer name, your name, a meter number, and then ether amount. Then you click make purchase. Now, of course, you know your ether balance already, but I think I also need to display that up here so that you get to see your ether balance as you're buying the energy. So if that's the case, then can just pick this, drop it here. I can say X balance 2. So you just get to see your ether balance. Should be this actually. So X balance 2 should be this. So if I were to refresh this page again, click on login. Click on buy energy. Good. So you see your wallet balance here. So all you just need to is enter a customer name, meter number, amount, and then make purchase. Now once you click this make purchase, we interact with the main function of this smart contract, and then we should be able to purchase energy. But before we do that, we need to deploy this smart contract, and then get the okay. How do I deploy this? Okay, so I've deployed this before. Okay, I need to redeploy it. Now we need to deploy this smart contract, and then you know, get to see what we're gonna do. So make sure you're connected to Ropsten Ether if you're deploying the smart contract. Make sure MetaMask is plugged in. Now we just need only MetaMask because we are deploying the smart contract. But to interact with the smart contract, we don't need to have MetaMask to be able to do that. And then make sure you select Energy Pay, not SafeMat. And then to deploy now, so the energy tokens, we're gonna give it name Energy Tokens, and then the symbol we say energy with GI, and then to 18 decimal place. So click on transact. This pops up MetaMask. So wait for this to come up. Good, so I deployed this smart contract. So wait for that smart contract to be mined. Good, so we have the smart contract mined, and we have our smart contract address here. So good. So now that we have that, we are going to call the function mint energy tokens. But before even calling that function, we can call the function get which is this balance of. So we're passing the address, and then we get the balance of the address, in which, as at this point, if we're passing our Ethereum address that we have, the balance of the energy tokens available to the address is 0. So we've not minted any tokens yet. And then if you get to click here, you can see the name of the energy token, which is energy tokens. Have the symbols here. The symbol is energy. So let's first of all call this function here balance, get balance of. So let's create that function so that we get balance of address that is logged in. Don't like this one, just some of this. So you can see here we get balance. This is Ethereum balance. So we're going to create another one, get energy balance. So just a function gets energy balance. Now in doing this, we need our API, variable API, which of course is this. If we come here, you can click on this to copy your API to clipboard. So now after pasting the API, we need the contract address, and then so we have that. So just a variable API contract address, which is what we have here. Here's our contract address. So we'll copy that. And then we'll paste that here. So here is our energy token smart contract address. And compressing my API should be web3.eth contract at where at API. And variable my function should be my API at contract address. Good. So now that we have this now, so my function dot calling this balance of, right? Passing in the address balance of. Let's call. So we're passing in the address of our of course, which is we have it here, X address. So I can just copy that straight away since we still have it on. So we're passing the address, and then function arrow, now result. The result of course is the transaction. So if there is a result, now we display the balance of that here, X token balance here. So X token balance. Did I spell it correctly? Okay, X token balance should be results, because that's what we are returning. So balance of the calling address. So get energy balance. Get energy balance. We're going to call that. Once we retrieve addresses, we get balance. Then we also get energy balance. Or you could actually pass these as a parameter here, but anyway, it's still going to work, I believe. So let's refresh this page again. So we enter our seed phrase. Click on login. Okay. I can see we are not retrieving that. So what could be the issue? So can I check? Let me just drop let me just check to see where the problem is coming from. So I copy this. First of all, let me check whether the function is called properly. So I just say checking. Let's try this. Okay, so it's displaying checking. Unless the function is called correctly. Let me paste it here and see whether we have opt there, whether we have everything correct. Okay, I can see checking is still displaying. So probably problem could be from here. So my function balance off, which of course call this call document that gets element by ID x address in a HTML. guess if I drop this here, I'm going to have an error, or rather I'm not going to see the but I would have put this and try and catch block actually. Let me do that. Let me do this. Try. These in a try and catch block. It will be much more easier. So that I can get to see the specific error. CATCH, and then here I catch the error. With this will display the error. So I can refresh this page again. Click on login. Good, so here's the error. Big number error. New big number, not number. Okay, it's saying this address is not a number. Balance off, and then yes, I'm passing this. Oh, that's a miss. Okay, I'm returning this. Balances of account. Oh, let me check that. So say I copy this address. Let's check it here. Good, so this returns 0, and then let's see why I'm getting this error. Or should I declare this like this variable? Address. I refresh these and do this again. Okay. Okay. Okay, let me still do something, and then see. Let's most Ethereum address starts like this: 0 by okay, good. So, well, I guess it's seeing these as a number actually, which is not supposed. And anyway, we see our energy token balance to be this, and then you can add this. Now, I call the function balance off. I can also call the function. I can also call this function. Function name, which is the name of the, or symbol rather, which is the symbol of the token. So we can just say symbol, and then I call that 2, and that has no parameter, right? So function SERR, and then SA results, a symbol results. Just give it any name that you feel like. So here now I can just pick this, or I can change this to name, as like name. Give a space and then name. So I get the name of the, or rather change it to symbol of the token. So let me log in again. So I paste this. Okay, good. So we have 0 energy as our token balance. Now the idea is, from here now you click to buy energy, you enter your customer name, meter number, and how much energy you want to purchase. And if you note, 1 ether gives 1000 units of energy. So once you click make purchase, we interact with this mint function here, interact with this mint function, and then return the value of the energy you have been able to purchase. So let's do that in the next video. Thank you for watching. Hi, continuing from where we stopped in the last video, we were able to display our wallet balance, and then we created this interface where you can make purchase of electricity by entering the customer name, the meter number, and the ether amount. And then we said that you should take note that 1 ether gives you 1000 units of energy based on what we have programmed in our smart contract. Now here now we are going to code the make purchase button, and then we're going to call the mint function on the smart contract to be able to mint energy tokens accordingly. So once you make payments, you make ether payments to the energy payment smart contract, the main function will be called, and then tokens, the energy tokens will be minted onto the caller's address accordingly. So let's get ahead and get started with that. Of course, I have the get energy balance function here, and then you can see we interacted with all this without using MetaMask. And that's the next thing I'm going to do now. It's I create the function means. I call this means. So this is one where you make your purchase of energy. So I put this in the try and catch block. So I say try, and then we catch an error. CATCH, catch an error, and then we start with the variable API. We declared the ABI, the application binary interface, contract address. Of course, just think we need up to this point. We just get this, and then I paste this here. Good. So now my function will call the mint. We'll call the mint function, but we need to check something first. Okay, we'll have X customer name, X meter number, and X amount. So I'm just gonna declare those as a variable. So you can say variable customer name should be document dot get element by ID. We'll say it's X customer name, right? X customer name. Just to verify this again. Dot value. So these are the parameters that I'm fixing. So meter number should be document get elements by ID, X meter number, value, variable amount, that's the amount of energy you're buying, the ether you're sending actually. We'll get element by ID, and then I call these X amounts. Good. So now I have these now, and then the amount should be converted to, because the amount is gonna be in way. So I'm just gonna convert this to ether. So you can just simply do that by saying Web3 and then to way. This value here to ether like this. Good. So and now my function should call the mint function, which is this function here. Let's comment, and then we'll pass in the appropriate parameters. The first one we have so we said the account that is calling, right? The account is going to be the wallet address that we have here. So it's going to be accounts that will and we have that stored in X address. So here it's gonna be the we're going to call that from these accounts. Which is the Ethereum address that we generated. So following the parameters, we'll have this. Then secondly, we have the customer name and then meter number. So the customer name is customer name, then meter number. Good. So from which accounts, of course, is this, and then we pass in a gas amount. Let's put the gas for with 6 zeros, and let's put a gas price that we're willing to pay. Let's put 3-way. So what 3.2 way. You notice that way is the smallest amount of ether that we have, which is about 18 zeros. Now the value should be the amount we're paying, which is amount that we declared, right? So function error and then results. So function error and then result. Let me see, am I making a mistake somewhere? I need this here. Nope. Okay, if I need this here now, then that is this. It's gonna be here. Good. That's how it's supposed to be. So we're minting this, and then if we mint it successfully, the receiving, the calling address, which of course is the wallet address we've created, will receive the energy token, the equivalent energy token of the value it sends. So, and we need to display these like in a way to show that what we have done is successful. And then where am I going to put that? Okay, I can put that here. I can just say tr, and then say td id message that we got, or result message. Just I can make this column span to be 2, since we have 2 columns. Okay. So if there's an error, let's capture that so that we get to see what error we have. Documents, let's get elements by ID. Elements by ID. We said result message in HTML should display error. But if there is a result, if it's successful, this to be resolved. I'm going to save this now. Now let me run these and see what I've got. I guess I also need to log out, so I need to log in. So I enter my password, click on login. So I go to wallet. I enter my seed phrase, which is what I have here. And enter password to decrypt your seed. Yes, click on that. Okay, I have a 0 energy tokens and 0.89 ether. So I go to buy energy. Customer name should be my username. You say meter number, let's say 11011. Here is the meter I want to load. Here's the meter, the machine I want to load with my energy, and then let's say I'm paying 0.12 ether. So let's click to make purchase. I haven't coded this, sorry. Make purchase. I haven't called the mint function. So on click event of this, I call mints. To do this again, to refresh this again. Okay, so I click to buy energy, and then I enter my username, say, and then here's my meter number, something like this, 0.11. Okay, it's not functioning. I guess we're having problems somewhere. So let's try and debug this a little. Okay, I didn't even catch the error. Like still need this. Still need to paste this here. Well, let me try it again so I can get to see the error. .11, for example. Oh, it's still this big number error stuff. Okay. Um, that is easy to save to solve. We can solve that easily. So I can just say put it up here. The customer address should be 0x plus this. So we can do this again. Enter our seed phrase. Click on login. Around 0.11, so we make purchase. Okay, why am I having this error? Let me look at it. Of course, here's my API, here's my contract address, and then here's the address I'm using. Just trying to get this error. Okay, from I need to change this to, of course I'm gonna have that error, so I'll change this to this value, and then let's do this again. Sorry, we just have to keep on debugging like this until we get it right. Click on login. Okay, well, still get this error. Something is actually null, and know where I'm getting this error from. Let me say inner error. Let's put this like this, and here let me put outer. I know exactly where this error is coming from. Okay, so the error is coming from here. That means the main function we were not able to call it, or called it and then we didn't get a result. I have gas here. Here's supposed to be gas price. That's where the error is coming from. So this is the gas, this is the fee, and then here's the price we paid for it. So just have to be careful sometimes. Just have to look through your program to get it up and running. Okay, so we'll click on buy energy, and then the customer, of course, is this username here, and then the meter number is this is the meter number he's paying you for, and then the amount he's paying 0.11 ether. So we'll click on make purchase. Whoa. Something is wrong somewhere, and it's just okay. Let me display my variables and make sure I display them correctly. I'm going to start with this. I'll just pick this. Let me display the customer address and see how it comes out. CUST address. To check spelling, sometimes UST address. Just checking everything. Okay. Okay, the address is displayed correctly. What is remaining? Customer name, X meter number, investor name, meter number, and XAMOUNT. Get elements by ID. Okay, let me see the amount. Maybe what I'm displaying is not correct. Yes, the amount is correct. So this should be 17 zeros. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17. So that's 17 zeros. And so where could this problem be from? Is it from our smart contract? Yes, it's not a zero address, and we'll add this transaction count. Good. Everything is okay in the smart contract. So why am I getting it wrong? Okay, I guess what I'm gonna do right now is pause this video here, and then in the next video, which of course is gonna be the conclusion, we're gonna provide solution to this. Probably I would have looked at it more carefully and see what the problem is and provide solution to it. If not, everything seems fine here. Account, customer name, meter number, and from this address, which is the address that is meant in this function, let's call it the mint function. And then here's the gas price, gas fee, gas price we're paying. Price we're paying, and then the amount we're paying for it. Now we check if there is an error result. Okay, alright, I'm gonna pause this video here and then continue in the next video and see. Okay, was I saving everything? Let me run this last time again, one more time. Let me run this one more time again and see. Commodified energy and then something like this, 0.21. Make a purchase. Oh, we have a problem there. Okay, all right, pause this video here, continue in the next video.